let's make some cookies. Yeah.
Why are you buying cookie mix, you ask? Your apartment doesn't even have an oven. Well, oven or not, I want cookies, so I'm gonna make them on my 3D printer. So that totally works. Anyway, this is actually an electronics video. I just felt like making cookies first. At SuperCon, I did a workshop about adding capacitive touchpads to a PCB. So I'm gonna make these little circuit board tea light things for the holidays and try and add as much capacitive touch functionality into it as I can. Just generally trying it out, because I've never really added that before and I really want to do it. It's just so cool when you just bonk, 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 and it reacts. It's just so magical. I want to put it in boards. So this is a little test to see how well it works. So here's the deal. I want to make a little tea light where the top surface is a PCB, and then there's two little capacitive touchpads that you can tap, which will turn the candle light on, which is really just gonna be an LED, and then another one to turn the flicker on and off. I want it to like realistically flicker like a flame, not just like be a solid on light, but kind of have like a little fluttery, flickery kind of look to it as if it's actually a candle. So just like every time I make a circuit board, I prototype it out on a breadboard first to make sure everything is looking the way it should be. And that greatly reduces the chance that I will make a mistake in the board if I know that all the connections that I made on the breadboard work. So here's what I made. So there's really not a lot going on here. There's a really, really tiny microcontroller here called an ATtiny85. It's just like the Arduino I normally use for most of my other projects, except it's just like its baby brother. It only has like 4 GPIO pins to be able to do stuff with, and a power and a ground pin and like a reset pin. It has very, very limited functionality. But this thing isn't really doing a lot. It just needs to control an LED and then a couple pins for the capacitive touch. And that's kind of it. Felt like overkill to put the whole AT Mega 328 that I usually put on my chips on this tiny little guy. You can see there's also an LED here, and then this big old aluminum pad thing. This is the surface that I'm using to test for my capacitive touch. It's actually surprisingly easy to add a capacitive touchpad to like any microcontroller at all. You just need 2 pins, 2 GPIO pins, a really big value resistor like 1 mega ohm or something. You can go bigger than that if you want to be more sensitive, and a small capacitor. Like that's literally it, and you have a capacitive touchpad. I'm not gonna go too much more into the details because there's a great write-up about it as part of the Arduino library that you can use to actually do this. I'll put a link in the description so you can check it out if you want to do it yourself. But with a little firmware magic, haha. Now when I tap this aluminum tape, it turns the LED on and off. I love it, it's so good. I like it. I'm gonna use CapTouch for everything now. It's so freaking satisfying. Anyway, I also put in the firmware the flickering effect. The ATtiny has a PWM pin, so I can make it put out a pulse at a certain duty cycle. All I'm doing for this is when it is supposed to be on, it just picks a random value to put out of the PWM pin, so it just kind of looks like it's fluttering. I pick a random value, put that out for like 20 milliseconds, pick a different value, put that out for 20 milliseconds, and the effect is kind of like this weird glitchy, flickery candle look. So I've already designed and ordered the boards, and this is what they look like. This cheeky bastard's got a port for the ATtiny85 like that was on my breadboard. It just has a different footprint that is surface mount, so I don't have to have the ugly holes poking through the top surface, which I want to keep nice and neat. These 6 little pads here are what lets me program the microcontroller while it's soldered to the board. It's called an ICSP header, and it pretty much just lets you program a whole bunch of different kind of AVR chips, which is the kind of chip in an Arduino. I made a little programmer on the Bantam Tools mill specifically to program AVRs with this footprint, so this is what I use for a lot of my boards now. You can also see the footprints that I put for that really big value resistor and a capacitor that I use for each of the capacitive touchpads. Then a footprint for a coin cell battery and the through-hole for an LED along with a current limiting resistor. And then of course the star of the show, these pads on the top surface, which is actually the capacitive touchpad that's kind of the end point of the sensor. One of the most important things I learned during that workshop at SuperCon about adding capacitive touchpads to boards is that you should not have any copper underneath it, or really around it at all. It should be super duper isolated, no other copper that would cause any stray capacitance or mess with your sensor value at all. You want to keep pretty much as much copper away from it as you can. Sweet, so now I'm going to perform the sacred ritual of component population and firmware bestowment and bring this beast to life. This is the first time I've ordered white boards, and they're so reflective, I literally need to wear sunglasses when I solder them. Ugh. They're just too bright. Oh man, this is just like, I cannot overstate how just magical this feels. I feel like in a lot of high-end products it has capacitive touch, so it just feels like something with capacitive touch is just inherently, I don't know, fancy. It was particularly tricky to tune the capacitive sensor values in my firmware. This chip is so small it doesn't have a serial port, which pretty much lets me just send data back to my computer to monitor. So I couldn't see what value I was getting from the sensor. I just had to write in a value and upload it and see how well that worked, and if it wasn't quite right, try a different one and upload it. I couldn't really see what was going on inside the microcontroller while it was running. It was a lot of guess and check. But eventually I got there. I found a nice constant value that seems to detect it pretty consistently. Cool, so this is the hard part done. The firmware was honestly the most tricky part. The board took me a while to get, but it really wasn't too complicated. There's only a handful of components in it. The only problem is it doesn't really look like a candle. Ah, there we go. Alright guys, that's it for this one. Thank you so much for watching. I'll be back in the new year with a 2020 channel trailer, and then back to your regularly scheduled Steven programming. And last of all, I want to thank this video sponsor, AllPCB. They cranked these boards out for me in under a week, and that is no small feat. These are 4-layer boards with some really weird requirements. And when I uploaded the Gerber files, an engineer from AllPCB reached out to me and said, hey, I think some of this stuff looks weird. Do you want to take another look at it? And she totally caught some stuff that I did wrong. I messed up, and I need to go back and make those changes. It's been really nice knowing that there's an engineer reviewing all my boards for silly mistakes before they actually go into production. If you're looking for a board shop to make some boards for a project you're working on, I definitely recommend checking out AllPCB. Tastes like a normal cookie.
That's very good. I'd eat that.
You are eating that.
I'm going to continue eating it.
Ah.